Today we're going to be solving radical equations. So an equation that contains radicals with variables in the radicand, remember that's what's underneath the square root sign, are called radical equations. So what we want to do to solve these is we're going to isolate the radical on one side of the equation, so get everything else on the other. Then we're going to square each side of the equation, and that'll eliminate the radical, and then you can go from there solving like we normally do. So that's kind of the process we're going to use. So in this first problem, if we want to isolate the radical, we need to get rid of the 1. So we're going to subtract 1 from each side and get the square root of 8x equal 4. Now that we have it isolated, next step, remember to square each side. Well, the square root of 8x squared is just 8x equals 4 squared is 16. So we divide by 8 and we get x equal 2. So not a whole lot to it, just follow the rules of what we've been doing. So in the next one, again, we need to isolate the radical. So we're going to subtract 7 from each side. We'll get the square root of x plus 1 equal 3. Square each side. So we get x plus 1 equal 9. Subtract 1 and you get x equal 8. Now, something I have not made you do is that we do need to check our solutions. Because when we square each side of an equation, sometimes we produce what's called extraneous solutions. So these are solutions derived from an equation, but they're not actually a solution to the original equation. So when you square something, you've got to be careful about what comes out of it. So you must check all solutions in the original equation when you solve radical equations. So we really should have been checking them, but I knew those didn't have anything. So that's a habit you need to get into, always checking. So let's look at this next one. So again, the radical is already isolated, so we need to square each side. So this gives me x plus 2. Remember, over here, you either write it out as x minus 4 times x minus 4 or use this special pattern. Square the first, multiply the two together, negative 4x, and double it, negative 8x, square the last, plus 16. So now what kind of equation is a quadratic equation, so we need to get it set equal to 0 so we can factor. So I'm going to subtract x, and also I'm going to subtract 2 kind of at the same time, so I can keep my x squared positive, and I'm just going to write it on this side. So I got x squared. If I subtract x from 8x, it gives me negative 9x. Subtract 2 from 16, it gives me plus 14 equals 0. So now remember, you need to go through your steps of factoring. Is there any thing in common? GCF, no. Difference of squares, no. Perfect square trinomial, 14 is not a perfect square. So it's kind of your guess and check, and since it is a factor of 1 here, you probably don't need to go through all the other process. So factors of 14 that are going to give me 9, well, I know it's going to be 2 and 7, and they both need to be negative. So I get x equal 2 or 7. And here's where it's important. You need to put them back in and check, and I just did this already on a slide here. So if we put a 2 in our original equation, which remember the original equation was the square root of x plus 2 equal x minus 4. So I put a 2 in here. 2 plus 2 is 4. The square root of 4 is 2. I put a 2 in here. 2 minus 4 is negative 2. So that did not give me a true sentence. When I put it in here, 7 plus 2 is 9. The square root of 9 is 3. 7 minus 4 is 3. So the only solution is x equals 7, and we would have to throw out x equal 2 as being a solution. So you need to always check that now that we know that. So don't think you don't have to do that every time. You should.